We are simplifying positive and negative square root of negative 16. So let's go ahead and get started with that negative sign. So when we have a negative square root, we can pull out an I, because I equals the square root of negative 1. And what we're left with inside is the square root of 16. Well, we need to pause for a moment. 16 is a perfect square root. The square root of 16 equals a plain old 4. So when we simplify this, the square root of 16 becomes a 4, and we put it right in front of the I. So that would be positive and negative 4I. Okay, here we have positive and negative square root of negative 72. Let's take care of the negative sign first again. And that leaves us with the square root of 72, but we need to pause and check to see if 72 has a perfect square root as a factor. So let's list the factors of 72. As we go through the list, let's look for the largest number that is a perfect square root, and that's 36, because the square root of 36 equals 6. Okay, so we're going to break this down. We have positive and negative I. The square root of 72, let's rewrite that as the square root of 36 times 2. And the square root of 36 equals a plain old 6. So we're going to pull that 6 out and put it in front of the I. So it's positive and negative 6 times I. And then the square root of 2 still tags along, times the square root of 2. All right, once again, let's start by getting rid of the negative sign by putting an I out in front. Now we need to think about the factors of 48. We're wondering if there are any perfect square roots that are factors of 48. So we look through here for the largest perfect square root, if there are any. There are two. Let's go ahead and choose the largest one, and we get 16. So we're going to rewrite the 48, or the square root of 48, as the square root of 16 times 3. All right, well, we know that the square root of 16 equals a plain old 4. So we're going to change that square root of 16 into a regular old 4, so it goes outside of the square root. So we have positive and negative 4I times the square root of 3. On that same problem, let's say that we hadn't realized that 3 times 16 equals 48 and had started with 4 times 12. That would still work. It just takes an extra step, and here's how it looks. So positive and negative, let's see, I, and let's say we chose to break that down as 4 times 12. Square root of 4 equals a plain old 2. So we're going to pull a plain old 2 out and put it in front of the I, leaving us with the leftover 12 inside the square root sign. But then we think about 12. And there are still perfect square roots that are factors of 12. We notice that 4 is a factor of 12, and the square root of 4 equals 2. So we need to keep going. So positive and negative 2I will break down that 12 into 4 times 3. The square root of 4 equals a plain old 2. So that 2 comes out front, or outside of the square root sign. All right, so now we have 2 2's. Normally, you wouldn't show this extra step, but what we're really doing is 2 times 2i, so we have our new 2, times the square root of 3, the leftovers inside the square root sign. Then we just, to finish this up, we need to multiply 2 times 2. So positive and negative 4i times the square root of 3. Let's do one more. So on this one, positive negative I times the square root of 22. And then we think about 22 and its factors. Well, that would be 1 times 22 and 2 times 11. None of these numbers are perfect square roots. So we're done here. So we have positive negative I times the square root of 22. We leave it just like that. I hope this tutorial has been helpful. Signing off.